let's get the door. Hey, welcome back to the 7th hour math lab here at Lewis and Clark High School. I'm Mr. Monty. Today we're working on Algebra 2, Unit 2. We're revisiting the systems of equations, and here's practice 006. One of those difficult context problems. Let's take a second and make sure that we understand what we're reading here. Lab technician needs to feed the rabbits a daily diet containing a minimum of 24 grams of fat, 36 grams of carbohydrates, 4 grams of protein. The rabbits should be fed no more than 5 ounces a day. Rather than order rabbit food that is custom blended, it's cheaper to buy food X and food Y containing 8 grams of fat, 12 carbohydrates, 2 grams of protein. Y contains 12 grams of fat, 12 grams of carbohydrates, 1 gram of protein. Then the cost, 20 cents per ounce on X, 30 cents per ounce on Y. Okay, let's get started. We need to put up a table of data. Food X, the fat, the carbs, and the protein. Food Y, fat, carbs, and protein, and the minimum required for each one. What is confusing is to set up our constraints or the equations that we can graph, we have to read from top down. So in the fat, it'll be 8x plus 12y greater than or equal to 24. The second one, 12x plus 12y greater than or equal to 36 in the carbs. And for protein, we'll have 2x plus 1y greater than or equal 4 ounces of protein. So that was the difficult part, was reading down in order to write these constraints. Now to graph, remember, I think it's a lot easier just to use your XY intercepts. So for the first constraint, for fat, we will have 3, 0, 0, 2. Connect the dots, and we'll call that fat. For the B, or the carbs, 3, 0, 0, 3. Again, connect the dots, and we'll call those carbs. The third column, or the protein constraint, 2, 0, and 0, 4. Connect the dots. Now the last constraint, and hopefully you saw it when you were reading it, but we're going to highlight it here. Rabbits should be fed no more than 5 ounces of food a day. No more represented by less than or equal to. So food X plus food Y less than or equal to 5. Those intercepts, 5, 0, 0, 5. Connect the dots. Now, let's see that on the last one, the food total has to be less than or equal to, so that's below the line. All the others were greater than. So let's take a second here and make sure that we can understand and highlight the feasible area. Yeah. Now, we have the feasible area. We're going to have 1, 2, 3, 4, 5 total points. So let's just mark these real quick. Go R, S, T, U, and V. So we're going to have 3, 0, 1, 2, 0, 4, 0, 5, and 5, 0. The confusing one might have been right here, where it's the intersection point of carbs and fat. Carbs and fat. Let's see here. What was that? Carbs and fat. Good catch. We don't need carbs and fat. We needed carbs and protein. Good catch. So if you weren't sure because the graph didn't work out quite right, carbs being the second equation, fat being the third equation, let's just do that real quick right up here. 12x plus 12y, we'll set it equal to 36 because we need the intersection point. 2x plus y equals 4. Well, we have a rule that can do that. It's called substitution. Y equals 4 minus 2x. We take this and plug it into the first one so that we can solve. 12x plus 12 times 4 minus 2x equals 36. And we're going to come up with negative 12x equals negative 12. X is equal to a positive 1. And that looks about right. Positive 1. We plug the 1 back in and we see that y is 2. So all of this, whenever we need to find an intersection point of two lines, we can use substitution to find it. Good. Now that we have our 5 possibilities for our feasible area, we need to go back and try to find the optimum blend. So we have our possibilities. And what was our optimum blend? Do we remember? Good. 20 cents per ounce on the X, 30 cents per ounce on the Y. So we have 0.2X plus 0.3Y equals our cost. And then real quickly we'll just calculate those. We have our 5 data points. Remember, whenever we have the data points, we actually plug them in to the parent function. The first one would be 60 cents. Second one, 80 cents. The third one, $1.20, getting more expensive all the time. Wow, the fourth one would be $1.50, a lot more expensive. And then our last possibility in the feasible area that we discovered would be $1. So our optimum blend is point R, which is 3,0, costing us 60 cents. Hopefully this made sense to you. This was our first time with multiple equations to create our feasible area for practice 006. If you need more help, make sure you stop by the math lab at Lewis and Clark during the 7th hour. See you next time.